In this topic, we will learn about Tyndall effect, Brownian movement, electrophoresis, and coagulation. Let's understand the Tyndall effect. When a strong beam of light is passed through a true solution, the path of light is not visible. However, when the same beam of light is passed through a colloidal solution and many other colloidal system, the path of light becomes visible with bluish light as shown in the figure, and this phenomena is called Tyndall effect. Here we can observe the Tyndall effect. This is the source of light and this is the true solution in which we cannot see any scattering of light, but in colloidal solution we can see the scattering of light. This is called as Tyndall effect. Tyndall effect is due to scattering of light by colloidal particles, and it can be observed when a fine beam of sunlight enters into room through a small hole. The dust particles dispersed in air scatter the light and path of light becomes visible. Similarly, when sunlight passes through a canopy of forest, colloidally dispersed small droplets of water in air scatter the light. Scattering of light by smoke or dust particle produces a rich red sunset. Milk also shows Tyndall effect because it is a colloid. Here we can observe the Tyndall effect. Here we can observe the Tyndall effect. This is the source of light, this is true solution, and this is colloid. We can observe that a beam of light is passing through the true solution without any scattering of light. But when the same beam is passed through colloidal solution, we can observe that there is scattering of light. This is because particles of colloid do not permit the light to pass through it completely. Therefore, the light beam is scattered by particles of colloid, and hence the path of scattered light becomes illuminated or visible, and this effect is called as Tyndall effect. We can take a daily life example. Tyndall effect is observed if sunlight enters a room through a small hole. The smoke and dust particles present in the air scatter the sunlight to produce this Tyndall effect. Next we have Brownian movement. When a colloidal solution is examined under ultramicroscope, the colloidal particles appear as tiny dots of light executing continuous zigzag random motion. This erratic ceaseless zigzag motion of colloidal particles in the dispersion medium is called Brownian movement or Brownian motion. This over here is the zigzag movement of particles and it is called as Brownian movement or Brownian motion. It was discovered by an English botanist, Robert Brown, in 1827. Because of Brownian movement, colloidal particles do not settle at the bottom of the container due to the influence of gravity. Next is charge on colloidal particles, electrophoresis. It has been established that colloidal particles carry electric charge that may either be positive or negative. When colloidal particles carry positive charge, the sol is called positive sol, example ferric hydroxide sol. But when the colloidal particles carry negative charge, the sol is called negative sol, example gold sol, arsenious sulfide sol, and starch sol. As colloidal particles carry charge, they move towards the oppositely charged electrodes when an EMF is applied over the colloidal sol. So here we can observe that when external EMF is applied, here we have the positive electrode and here we have the negative electrode. The positive electrode is called as cathode and the negative electrode is called as anode. We also know that colloidal particles carry charges. So the charge on colloidal particle can either be positive or negative. If the colloidal particles carry positive charge, they will move towards the negative terminal, that is anode. And if the colloidal particles carry negative charge, they will move towards the positive terminal, that is cathode. This is because unlike charges attract each other. And as colloidal particles carry charge, they will move towards the oppositely charged electrode when an EMF is applied over the colloidal solution. Therefore, in case of a negative sol, example arsenious sulfide sol, the colloidal particles move towards the positive electrode as shown in figure. So here we have the figure, and in this case we can see that this is the positively charged electrode and this is the negatively charged electrode, and this arsenious sulfide sol, which is negatively charged, is moving towards the positively charged electrode. This movement of colloidal particles either towards anode or cathode under the influence of external EMF is called electrophoresis. The charge on colloidal particles is the main factor for the stability of salts. Due to mutual repulsion between similar charged colloidal particles, they prevent from aggregating to form bigger particles when they come close to each other. Next is coagulation. If the charge on colloidal particle is decreased or removed, the colloidal particles will come closer and aggregate to form large particles which settle as precipitate. This phenomena is called coagulation or precipitation. Therefore, when an electrolyte such as NaCl is added to the sol, the charge on colloidal particle is neutralized by oppositely charged ion of the electrolyte. Now devoid of charge, the colloidal particles will aggregate together to form bigger particles which will settle as precipitate. I hope this topic is clear to you. Thank you.